So in this video we're going to calculate the area enclosed by two modulus graphs. So we've got 2x minus 6 in the modulus and subtract 4, and we've got 5 minus x minus 3 in the modulus. So what I've got is I've set up some axes here, and what we'll do is find out what's going on this so we can clearly understand what's going on in the question. So first of all, let's graph 2x minus 6 in the modulus minus 4. So what we want to do is find on a modulus graph where this point is. So a modulus graph will always have a symmetrical show with a maximum or a minimum point. So if you can find these points, then we can draw the graph nice and easily from there. So this one here has got a positive sign here, and then a modulus of 2x minus 6. So this will be a shape looking like this one, a bit like in quadratics when we've got a positive for the ax squared, we have the smiley face, very similar. So what we're going to do is here set this to 0. So we want 2x minus 6 equals 0, so that gives us 2x equals 6, x equals 3. And if we plug in 3 in here, this will obviously be 0, and then we'll be left with minus 4. So our coordinates of our minimum point will be 3 minus 4. So let's plot that on the graph. There's 3 and minus 4 is here, so that's our minimum point. The next bit we want to do is to find out when it's going up in this direction. The easiest one to look for is when it crosses the y-axis. So at the y-axis x is 0, so plugging 0 into here, we've got 2 times 0 minus 6 and then minus 4. So 2 zeros are 0, minus 6 is minus 6. So we've got minus 6 minus 4. Inside the modulus this becomes 6 and then minus 4, and that equals 2. So when x is 0, we've got y is 2. So we've got 0, 2. So it's going to go there. So therefore our graph is going to go up in this direction, intersecting that point there, and then it will go the same over this way. Now the way to find out where it's going to go in this corresponding point here, we've got 2x minus 6 there, which became minus 6 when x is 0. Now when that becomes positive because of the modulus, we get plus 6. Now the other way we can get plus 6 is by making this 3x value, this 2x value into 12. So when 2x is 12, we still end up with 6. So let me just show you what that is. So 2 times something is 12. Well, 2 times 6 is 12. So 2 times 6 minus 6 minus 4. So again, we've got 12 minus 6 minus 4. And again, in here, we've got absolute value of 6 minus 4, which equals 2. So again, here, our x value will be 6, but our y value will be 2. So a modulus function is always many to 1. So 6 to 2. So when x is 6, 3, 4, 5, 6, our y is 2. So our graph will go up in this direction. Obviously, if you've got a ruler, you can make that a nice straight line. So that takes care of that one. Now let's do the same we did here with this one. So we've got 5 minus the modulus of x minus 3. Now this one, because of this minus sign here, is going to make this shape. Just again, like in quadratics, when you've got minus ax squared, you get the frowny face. So let's work out this. So what makes this 0 to find this maximum point? So what we're going to do is set x minus 3 equals 0. Nice straightforward algebra. So x equals 3. So we've got x equals 3. Now what happens when we plug in 3? We've got 5 minus 0, so therefore it's going to be 5. So our maximum in this case is at x equals 3, y equals 5. So let's plot that. 1, 2, 3, 4, 5, and there's 3. So that's our maximum. So we want to know now where it comes downwards and what points it touches. So the easiest way to do is to plug in 0. So then we've got 5 minus 0 minus 3, which becomes 5 minus 3 in the modulus. In the modulus, obviously, that becomes positive. So we've got 5 minus 3, 2. So then we've got our coordinate where it intercepts the y-axis is 0, 2. So at 0, 2, so x is 0, y is 2, so it intercepts the same place as this one intercepted. So it's going to go down something like this. And then in this direction, so what do we have here? We have x minus 3, which gave us minus 3. So another version of that was when this becomes 3. Well, that becomes 3 when x is 6. So let's find out what happens when x is 6. So we've got 5 minus 6 minus 3. So that becomes 5 minus 3 in the absolute value. So then that equals also 2. So our other point is going to be at when x is 6, we've got the y coordinate of 2. So 4, 5, 6, y coordinate of 2. So same again as this one. Okay, so that's our graph of this one coming down in this direction. So now we're clear with our diagram for calculating the area enclosed between these two. So we want the area enclosed inside here. Okay, so how are we going to do that? Well, as we've got meeting points here, and these two here are both on the line of x equals 3, we've got a kite shape. So what we can do is, if we just do a dotted line around the outside, turn that into a box, and that's obviously the y-axis. What we can do is find this length and find this length. So our changes in x will be 6, and then changing y, well, I've got a value here of 5 and a minus 4. So 5 here and minus 4. So changing y equals 9. So then I've got a rectangle of area 54. So rectangle area equals 6 times 9, which is 54 units squared. So then, as it's a kite shape, all I have to do now is divide this by 2. So as it's a kite shape, area equals 54 divided by 2, which equals 27 units squared. And that is our answer. Okay.